Hello and welcome. We've got this Origin 20 back on the bench, and the reason for that is we've had a couple of comments from watchers saying that when I biased this amplifier they thought that I got this set on the mid power control on the switch, which if we just ease the camera back you can see there, this three-way switch. So that's low, medium and high power going on there. Now I was pretty adamant that I had set that on the high setting, and when I looked at the video, when I played the video back, it did look like it was on the high setting, but decided that I'd do a video on this just to clear this up. And one of the watchers did point something out that was actually quite valid, which I really should have done, and that was to test the bias on all three settings so we can get a dissipation of each of those settings, which I didn't do. So that's what we're going to do in this video. We're going to check this bias. First of all, we're going to see whether I did make a mistake, because I am a bit of a dummy sometimes, and we're going to test it and we're going to see. Right, so what we're going to do is we are going to check this bias. So we've got 150 ohm bias resistor there. It's cathode bias, this amplifier. So we're going to measure the drop across that resistor. We are on high, so let's just confirm this before we go on. So we'll turn the amp up, you can hear the white noise. So that's on high. Mid, you can hear it drop. Low goes lower. So we're on high. Turn the volume down while we're testing. A little bit, that's good. Right, so you should just be able to see the meter over there. So you can see we've got 16.48 volts across that. So we need to write that down. So where's my pen? There it is. 16.48 volts drop across that resistor. We already know the resistor's at 150R. So now what we need the voltage plate to cathode. So if we go there and we go to the plate there, we can see that's 251.6 volts. Let's do the maths on that. So that's 109 milliamps for both tubes. So if we divide that by 2, we've now got 54.9 milliamps. $54.9 We take away 5% for the screen, that leaves us with 52.1 milliamps, or 52 milliamps is near enough. And then if we times that by our voltage of 251.6, we get 13 watts of dissipation. 13 watts. So when I checked this last time, I got 12.5 watts, 12.5 watts. So the voltage on the main supply is probably just up a little bit on there, but 12.5, 13 watts with it. So I actually did test this on the high, but I thought I'd check anyway, because just to be sure I'd done this right. So we know we've got that right, but of course what I didn't check was the other two settings, which I really should have done. So mid power on this setting now, and I've clicked that now into mid power. Would we think, well, that if that's mid power then that's about halfway. So we've got 13 watts on these tubes, which I think is a bit low myself, but anyway, it really doesn't want to be much more dissipation, otherwise this transformer will be a light, because that's a lot of current for a small transformer. So what we'll do is now on mid, we're going to check across the cathode resistor again. and now we've only got a drop, and if you can just see that, 6.87 volts. So now we'll write that down. 6.87 volts. We know our resistor is 150 ohms, so we just need the plate to cathode voltage. And now our plate voltage is 290 volts on there. 290 volts. So before we go any further, we'll do the maths on that. 6.87 divided by 150 equals, divided by 2 equals, so that's 22 milliamps, 22.9 milliamps for each tube. And if we times that by 290, we get 6.6 watts. So that is half. So that is actually half power, technically. 6.6 watts. So let's try the low setting. So we've flicked onto low. Let's look at the resistor again. So now we've got 3.5, we'll call that, near enough on the low setting. So 3.5 drop across the resistor. We know again 150 R for the resistor, so we just need plate to cathode voltage. So if we go there and we go there, and now the plate to cathode voltage is 308.5. So if you put that down, 308.5, so let's do the maths on that. So it's a 3.5 drop divided by 150 equals, divided by 2 equals, take away 5%, and if that leaves us 11 milliamps a tube. 11 milliamps, times that by 308.5, and we get 3.4 watts, 3.41, so 3.4 watts there. Excuse me, I've still got this nasty cold, although it is going now. So we've got on the high setting, which we're on now, we've got 13 watts. On the mid setting we've got 6.6 watts, and on the low setting we've got 3.4 watts. But what we need to look at now is what the voltage is on the screens to cathode. Oops, sorry, bumped the camera again. So let's have a look at that now. So we'll just go in there. So we're on the high setting now, and if we go on to, the voltmeter swearing at me. So let's look at the screen. So the screen voltage, you can see, is 243 volts. That's on the high setting. So on the high setting, 243 on the screen, or grid 2 as it's known. Let's go on to the mid setting and we'll check again. $101 volts now on the screen. So you see that that screen volt's been reduced over 100 volts. 101. And then that's on the mid setting. So let's see what it is on the low setting. It's obviously going to be under 100 volts. So we're expecting somewhere around 50 volts, if that's half again. So let's give it a look. Whoops, hang on a minute. There we go, 48 volts, and it is indeed half, virtually half again, which is half again. So 48 volts on the screen. And that's what I actually should have done in the first place, in the first video, as opposed to what I actually did. I kind of skipped over that and didn't do it properly. So that's given us some figures there on that. Now how this actually is wired in the circuit and everything. I don't have a schematic for this amp, so I can't really see how that's wired. I don't know how they're doing that, but that's basically how it's being scaled. They reduce the screen voltage on each setting. That will increase the plate voltage, for the simple reason the screen is drawing down as the screen is dissipating. The screen will draw down the voltage as a whole. If you reduce the screen voltage, you will increase the plate voltage, but it also stars the current to the tube, which will obviously then drop the dissipation. That's basically how that's working. I'm sure there's some techs out there that can explain that better than I can. Now, the other thing that was brought up in the comments on this video was the type of glue that I used on these capacitors, and the same watcher that actually brought up this valid point about this, checking this high, mid and low dissipation, said that using hot glue, there could be a possibility that it may melt. And obviously hot glue does melt with heat if you put excessive heat on it, hence that's how the gun melts the sticks. So I run this amplifier up for a couple of hours after I'd finished the repair. In its case, it was buttoned up in its case. After a couple of hours, I took the top off again and just checked everything inside, and the glue's absolutely fine. Don't get me wrong, the board gets warm, but not to the point where it'll melt the glue. But again, a valid point, and I think probably next time I do an amp like this, I'm going to use silicone instead. So and obviously I've got to be careful what I put on this plug here, because if anyone comes to take this board out, they've got to be able to easily pull off the hot glue, and it does pull off pretty easily, so there's only a smidgen on there. So that basically has covered most of those comments, and I do welcome this discussion on the channel. You know, if somebody sees something on one of the videos, you know, and they question it, that's fine. I have no problem with that, and this has made another interesting video for you all to watch. But there was one other comment, and that was from Lyle Caldwell from Sonic Audios. I can never pronounce that, you know. but yeah, that obviously a fantastic tech. And Lyle pointed out that well, he actually pointed out, because I mentioned about putting 6v6s into these amps, which he actually pointed out basically that, you know, that's where they should have gone with it. But he also pointed out, also said in the comments, that there's also 2-watt resistors in this amp that are dissipating more than 2 watts. Now, obviously, when I opened this amp up from the start, I didn't see any baked resistors, and I still can't see any baked resistors. But obviously, if he says that that's the case, then that is the case. Some of these resistors then are not up to the job, basically. Now, I was asked to do a repair on this amp and get it running. Unless I see any resistors that are baked, and I don't see any evidence of that in here, I haven't obviously not delved into it that far. And also, if it's a 2-watt resistor, chances are it's going to be a drop-in resistor or something on the power. I don't do topside repairs on PC boards. Doing them on the power, on the drop-in resistors, is a bit iffy. I mean, smaller resistors, people do it, and that's fine, but I don't do that. I don't do topside repairs. I've not really obviously delved into that, and I'll certainly take Lyle's word for that, that is the case with these amps. That, you know, he's obviously been through these with a fine-tooth comb a lot more than I would have done on this one. So I would like to do a turns ratio test on this transformer, and when I did the maths on it, I got 5k for the primary. Now, I'm not saying that transformer is 5k, I'm saying the maths that I did based on the voltages and dissipation came out at 5k. But here, this is where I see the problem with this power scaling thing, the way they're doing it with the screens. And my maths is not always deathly accurate, but if you have, and I've just done the maths on this, so the voltage increases on the plate, but the dissipation goes down. So normally, by my understanding, to get the primary from the voltages when the amp's obviously running is to take the plate voltage, plate to cathode voltage, and square it and divide it by the dissipation, which is how I got the 5k. So that would be the voltage. It's actually 4,862, but we generally, it's that close, it's rounded off to 5k. So that would be from the voltage that we took off the bias, which was on the high setting was 251 volts. Now on the mid setting it's 290 volts, but the dissipation is only 6.6, and the maths on that comes out at 12.7k primary, and on the low the maths come out at 27k primary. Now I may be missing something here, because as I've said, you know, there's techs out there far more advanced than I am. You know, some of these guys build amps, whatever else, but I cannot see how you can scale the power, and to me it's in the word scale, to scale the power and maintain the same effective load resistance on the tubes. The effective load resistance should match the primary of the transformer. So what I'm actually testing here is the effective load resistance. So 5k, 12.7k and 27k, based on squaring the plate voltage and dividing it by the dissipation. And that we've got 3 settings, so we've got 3 different dissipations, 3 different plate voltages, so we've got 3 different effective load resistance. That's how I read it. So obviously I'm going to offer this out for discussion. Whereas if you were doing this like those VVR kits that they buy, variable voltage regulation, you're then doing it with the plate voltage. So although you're actually then dropping the plate voltage, but you're actually then dropping the dissipation as well. So that to me is a scale. It stays on a scale, which is obviously going to be more accurate to the effective load resistance. But anyway, so I'd be interested to know what you know, some of you techs out there, what your thoughts would be on that one. Now I could do a turns ratio test on this transformer, but not the only reason I wanted to, because it's on, I've just looked, it is on spade connections. In fact, there looks like somebody's had a go at taking that one off, because there's you probably can't see it, but someone looks like they've slipped with the screwdriver there, trying to find why they'd be taking that off. I don't know, but or maybe it's just an accident when they were making it. It's nothing serious, it's only a scratch. So the only reason, as I said, I wanted to do that turns ratio test is to see if we could put 6 V6s in this amp. Now if that is 5k, and we put, because normally what couple of, it depends how much, obviously again on the plate voltage, but I would have thought when we put, because these tubes are drawing like 55 milliamps a piece, even though they're dissipating 30 watts. Normally when you put a pair of 6 V6s in there, you're probably dissipating about 38-40 milliamps, so that plate voltage is going to rise. So technically, normally for a pair of 6 V6s, you're looking around an 8k primary, and the maths will usually come out with a plate voltage of an 8k effective load resistance, so they'll match. But in this case, I don't think that will match, because I'm pretty sure that'll be 5k. It could be less, it could be 4k, I don't know. But I'm actually not going to do that test this time on this amp, because it's a customer's amp. It's now up and running and finished. I've got to prise all these terminal things off and then test it all and mess about. And to be fair, looking at the way they've done this power scaling, it's I think I'll just button this amp up. But I would like to do that in the future if I get another one of these, or we get one come in the shop. If Lee gets one coming in the shop, then you know we can do more to it, because again, to be fair to the customer, this came in for a basic repair, which we've done, and it's probably not fair to start pulling his amp to pieces and testing on it, is it really? So I'm actually not going to do that. Voltage testing, that's different. So I think that'll wrap it up for this one, and I appreciate all the comments and all the, you know, and the guy that again that brought this particular thing up about testing this power scaling, you know, through the actual switches, you know, low, high, mid and low. I thank him for that, because that that just never, I don't know why, I just never thought to do that, and really that's, you know, that's good information that we've got there, and we can share that with everyone on the channel. So thanks for watching, and you all take care, and I'll see you all in another video. Bye bye for now.